All right, so let's look at the test 2 review for this exam. The test again is going to include sections 3.1 through 3.4. It'll also include 4.1 through 4.3. Now, as we're working through these, we'll be toggling back and forth between the questions for this test review and then the responses. The reason we're seeing that is because you see now that in this first problem, we can't see what the question was, or the question itself is. All right, so we're going to look at the first question, which is write the inequality using this interval notation. So we have this inequality, x less than 2. We want to write this inequality using interval notation. When are values of x less than 9? So values of x are less than 9 here. Since we saw our symbol as being less than, remember you're going to use parentheses. So if values of y are any number that's less than 9, that means on a number line, we have 9 here, we would be shaded in the direction of negative infinity. It could be any number that's smaller than 9. So negative infinity with parentheses. You always use parentheses for infinity, and then 9 with parentheses. So y could be any number that's less than 9, not 9 itself, but numbers that are smaller than 9. Problem number 2, you're asked this statement. We're going to find the number if the quotient, that word quotient, of a number and 5 equals 7 more than the number. So a number and 5 equals 7 more than the number. The word quotient means to divide. So we're dividing two things. We're dividing 5 and 7, well, some number in 5, but it equals 7 more than that same number. Since we don't know what the number is, we would find the quotient of x and 5. So we're dividing x and 5, and that equals 7 plus x. So the quotient of some number in 5, x over 5, equals 7 plus that number, so x plus 7. We're solving this equation, and we're going to get rid of the fraction first. Since we're dividing by 5, we're going to multiply each term in the equation by 5 to get rid of that denominator. And 5 and 5 will cancel, leaving x on the left side of the equation. On the right side, 5 times x gives us 5x. 7 times 5 gives us 35. We'll start solving here, right? We want to, now that we have x on the left side by itself, we're going to combine these like terms. This 5x, to combine it with the 1x on the left side, we're going to subtract 5x from both sides of the equation. 5x will cancel, and 1x minus 5x gives us negative 4x. Divide both sides by negative 4, and we'll get x equals negative 35/4. Now the second equation, we have 7x plus 8 equals 7x minus 9. That a problem is just to solve. When we solve this equation, we'll go to combine these like terms. So we'll subtract 7x from both sides of the equation. 7x will cancel, so we'll carry down our negative 9. 7x cancels again, we'll carry down our 8. 8 does not equal negative 9. Therefore, there's no solution. And then we're solving for number 4. We have 15x plus 8 equals 4x plus 8 plus 11x. We were given that equation. We had to distribute 4 times x and 4 plus 2, or 4 times that 2, right? We'll combine like terms. the 4x and 11x can be combined. They're on the same side of the equal sign. So 4x plus 11x gives us 15x. Carry down the 8. And then we'll go to combine like terms. Subtract 15x from both sides of the equation. The 15x's will cancel. When the 15x's cancel on both sides, what's left over? We have 8 on the left side, 8 on the right side. Now those two terms are equal. That means it doesn't matter what we substitute for x. We'll always have two terms that are equivalent. Therefore, our solution could be any real number. We have infinite number of solutions there. For number 5, we're solving for y. We have 5x or 5y, 8x is equal to 13. After we solve for y, we want to find the slope and the y-intercept. So we have 8x plus 5y equals 13. To solve for y, we'll start by subtracting 8x from both sides of the equation. The 8x's will cancel over here on the left, leaving 5y equals negative 8x plus 13. Then you want to divide both sides of the equation by 5. The 5's will cancel. So y is equal to, remember you're dividing both of these terms over here on the right by 5. Negative 8 divided by 5, that's negative 8/5 x. And then 13 divided by 5, 13/5. So what is our slope? It's negative 8/5, the number in front of x. And our y-intercept is 13/5, the number behind x. Now problem 6, we're given this statement. The sum of 3 consecutive odd integers is 39. We want to find those integers. So consecutive odd integers, remember it's 2 spaces between odd numbers. If we had the odd numbers 1, 3, and 5, for example, these are consecutive because they're back-to-back odd numbers. But how much space is between 1 and 3? It's 2 spaces. How much space is between 3 and 5? Again, 2 spaces. But to go from the first point, 1, to the second point, we add 2. So this is our second number. Then to go from that first point, if we said this first one was x, to the third point, we would have to add 4. So this would give us, x plus 4 will give us the third number, the third consecutive number. You're told that the sum of those 3 consecutive odd numbers is 39. So we add these 3 expressions together, x plus x plus 2 plus x plus 4, and we'll set it equal to 39. You want to combine your like terms. So x plus x plus x gives us 3x. And then 2 plus 4 gives us 6. So we'll go to solve this equation. We're going to subtract 6 from both sides and divide by 3. 3x equals 33. We divide by 3, and we'll get x, or the first number is 11. And the next 2 odd numbers will be 13 and 15. You can get that here by substituting 11 plus 2 to get 13, and then 11 plus 4 to get 15. Now for number 7, we're solving this equation that has decimals, 0.3x plus 0.7, and in parentheses 4 minus 5x equals 0.8x. When we have equations that have the decimal points, we want to get rid of those decimal points. So we got to figure out what is our place value. Like each of these numbers, the decimals, are in what space. This is in 0.3, which is the 10th place. 0.7 is the 10th place again. And on the right side, 0.8, that's in the 10th place. So to get rid of those decimal points, we're going to multiply by 10. Multiply every term in that equation by 10. And you'll see 0.3 times 10 gives you 3x. 0.7 times 10 gives you 7. And then 0.8, that's a negative 0.8, gives us negative 8. From there, we want to distribute. 7 times 4 gives us 28. And 7 times the minus 5, that gives us negative 35x. Carry down your 3x in front, your equal sign, and the minus 8x behind. We'll combine like terms on the left side of this equation, 3x and minus 35x. That gives us negative 32x. Carry down your 28, your equal sign, and your minus 8x. We'll go to solve here. Now, you'll notice that if we carry that 28 over here, we still need to combine these x terms. So it's a little bit easier just to leave this 28 in place and remove this 32x. So we'll carry the 32x to the right by adding it. When you add 32x to the right side of the equation, negative 8 plus 32, you'll get 24x. On the left side, the 32x will cancel. We'll divide both sides of the equation by 24, and we'll get x equals 28 over 24. Now 28 over 24 can be reduced. We can divide both of those terms by 4. 24 divided by 4 gives us 6 in the denominator, and 28 divided by 4 gives us 7. 7, 6 will be the lowest term. Now example 8, we're graphing the inequality, y less than 5x minus 3. So this is similar to the 4.3 homework we just looked at. Our slope right here is 5, our y-intercept is negative 3, and this is our starting point. So we should start at negative 3 on the y-axis. 1, 2, 3, plot the point. Since our slope is 5, that means we're going to move up 5 spaces and right 1. We're starting at negative 3, we're going to go up 5, right 1. 1, 2, 3, 4, 5 up, right 1, plot the point. Now we got to decide whether we're shading to the left of this line or the right of this line. To do that, we're going to test 0, 0. We're testing 0 for x and 0 for y into our inequality. So when 0 is here, we have 0 less than 0 for x, so 5 times 0 minus 3. 5 times 0 is just 0. So is this a true statement? Is 0 less than negative 3? No, that's not true. 0 is not less than negative 3. So we won't shade on the side that has 0, 0. We'll shade on the opposite side. Also, we connected those 2 points with a dashed line because our symbol was less than. Now for number 9, you have a system. You have a compound inequality. You're solving for x, so you're trying to get x by itself in the middle of these 2 inequality symbols. To get 5x minus 1, to get this x by itself, you're going to add 1 in the middle, you're going to add 1 on the left, and you're going to add 1 on the right side. So all 3 sections in the middle, on the right, and on the left. When you add 1 in the middle, you're left with 5x. On the right side, 9 plus 1 gives you 10. On the left side, negative 8 plus 1 gives you negative 7. Lastly, you want to divide all 3, the middle, the right, and the left, by 5. So the 5s will cancel here, leaving x. On the right side, 10 divided by 5 gives you 2. On the left side, negative 7 by 5 gives you negative 7/5. Now, writing this solution in interval notation, you'll have negative 7/5 Our symbol is less than, so we should put parentheses around -7/5, comma 2, parentheses around 2 as well. So this will be our integral notation for this solution. All right, so example 10, we have on this XY grid, so we have a coordinate plane. We're going to draw a line that has a positive slope and then another line that has a negative slope. And we're going to show that those two lines intersect in quadrant 1. So if we have an X and Y axes, so we have a line that goes up and down, we have a line that runs left to right, our X axis, you'll see 4 quadrants. 1, 2, quadrant 3 is in the lower left, and then quadrant 4 in the lower right. We want to draw in the first quadrant 2 lines that intersect, one with a positive slope and one with a negative slope. So positive slope means that the line increases, it goes up from left to right. Negative slope means the line decreases, so it goes down left to right. And then here, these 2 lines intersect, they touch each other in quadrant 1. So that will be an example of 2 intersecting lines, one with a positive slope and one with a negative slope, intersecting in quadrant 1. Now, problem number 11, we want to draw a linear system that has the solution that is the empty set. So we want to know, what is that graph that has no solution? What does that system look like? That system looks like 2 parallel lines. And this system has no solution because these lines will never intersect each other. They're never going to touch like example 10. Therefore, they have no solution. Now, because you have no solution, you also can write this as parallel lines. Any graphs of parallel lines, you'll notice you have no solution. All right, let's look at number 12. Number 12 says, draw a linear system whose solution set contains infinitely many points. So we got an infinite number of solutions. Now that graph is the graph of a single line. So you'll just show coordinate plane, X and Y axis, with one line. The reason it'll just be one line because your system will have two lines with the same graph, meaning those 2 graphs are going to be right on top of each other. So this will be an example of a graph that has infinite number of solutions. All right, let's look at number 13. We're solving this inequality. 7 minus 2x over 3 less than or equal to 4x plus 1 over 5. Now, given that we have 2 different denominators, in order to get rid of this fraction, we have to find that least common multiple, this time between 3 and between 5. Remember, the least common multiple, we would list multiples of 3, so 3, 6, 9, and so forth. We'll list multiples of 5, 5, 10, 15. The smallest multiple that 3 and 5 has in common is 15. You will multiply each of the terms by that least common multiple of 15. And 3 goes into 15 5 times. So we get this 5 here. 5 goes into 15 3 times. We get the 3 there. times the numerators. So we carry down the 7 minus 2x, carry down the 4x plus 1. From there, we want to distribute. So on both sides of the inequality, we're distributing. 5 times 7 gives us 35. 5 times the minus 2x gives us negative 10x. 3 times 4x gives us 12x. 3 times 1 gives us 3. So we're combining like terms, these x terms, we're going to subtract 12x from both sides. We're also going to combine the constants, so we're going to subtract 35 from both sides of the inequality. Now on the left side, 35 and 35 will cancel. Negative 10x minus 12x leaves us with negative 22x. On the right side, the 12x will cancel, and 3 minus 35 gives us negative 32. We'll then divide both sides of the inequality by 22, negative 22. Now remember, whenever you divide by a negative number, you got to reverse that inequality symbol. Because we're dividing by negative 22, we reverse the symbol from less than or equal to greater than or equal to. So we'll get x greater than or equal to 32 over 22. And both of these can be divided by 11 or divided by 2. So we're dividing both the numerator and the denominator by 2. 32 divided by 2 gives us 16. 22 divided by 2 gives us 11. So our solution to the inequality is x greater than or equal to 16/11. And in interval notation, because we have that greater than or equal to, 16/11 should have a bracket. And we're shading in the direction of positive infinity. So we should have parentheses around infinity. You have a similar inequality for number 14. 7 times 2 minus x greater than 3 times 2 plus x. We have to distribute on both sides of the inequality. So we'll get 7 times 2 or 14. 7 times the minus x gives us negative 7x. 3 times 2 gives us 6. And 3 times 2, 3 times x gives us 3x. You want to combine like terms. So you notice your x terms, you need to combine those. We're going to subtract 3x from both sides of the inequality. And then the 14 will carry over to the right side. It's positive, so we're going to subtract 14 from both sides of the inequality. On the left, we have negative 7x minus 3x gives us negative 10x. And on the right side, we have 6 minus 14 gives us negative 8. We'll divide both sides of the inequality by negative 10. Now, because we're dividing by that negative, we'll reverse the symbol from greater than to less than. And x is less than 8/10. We can simplify this again. We can divide the top and the bottom, the numerator and the denominator, by 2 to simplify this fraction. 8 divided by 2 gives us 4, and 10 divided by 2 gives us 5. So that solution, x less than 4/5. So less than 4/5, this time we're shading in the direction of negative infinity. Comma, 4/5, we should have parentheses around 4/5 because our symbol is less than, so our interval notation here. What you notice for number 15 is now we have two separate inequalities that are separated by and. We're going to solve the inequalities separately. The inequality on the left, 5x plus 2 greater than or equal to 22, we solve by subtracting 2 from both sides first. We'll have 5x greater than or equal to 20, and then we divide by 5. x greater than or equal to 4. So this is the solution to the inequality on the left side. On the right side, x minus 1 less than 13, we'll add 1 to both sides of the inequality, and we'll get x less than 14. So we want to know the solution set for x greater than or equal to 4 and x less than 14. So if we were to graph that first inequality, x greater than or equal to 4, we would have a bracket at 4 and we would shade to the right, the direction of positive infinity. If we were to graph the second inequality, x less than 14, we would have 14 on the number line with parentheses and shade in the direction of negative infinity. Now, where's our combination for both? We want to know values of x that fit both of these ranges. Greater than or equal to 14, less than, well, greater than or equal to 4, and less than 14. So greater than or equal to 4, right here, that boundary, that highest point we want is 4. So we use the bracket and 4. The lowest point we want is 14. So we use 14 with parentheses. Therefore, that range that encompasses both inequalities would have bracket 4, comma 14 parentheses. So for 15, we had our two inequalities separated by the word and. For 16, we have the two inequalities separated by the word or. So it's a little bit different. We still solve both inequalities separately. So the inequality on the left side, we're going to add 11 to both sides of the inequality. And we'll get x less than 31. Or on the left side, negative x, we want to see that as negative 1x. Plus 2 less than 15, we'll subtract 2 from both sides. And we'll bring down our negative 1x less than negative 17. Then we're going to divide both sides of the inequality by negative 1. So x is greater than positive 17. We divide negative 17 by negative 1, we'll get positive 17. So if we were to graph this first inequality, x less than 31 on a number line, we have 31 with parentheses, less than 31, so we're shading in the direction of negative infinity. If we were to graph the second inequality on the number line, we have x greater than 17, so at 17 we should have that parentheses and shading in the direction of positive infinity. So what is the section that represents x terms that are less than 31 or x terms that are greater than 17? It could be any real number, because that encompasses the whole number line. Numbers that are smaller than 31, so starting at 31 and smaller than 31, and numbers that are bigger than 17. So from 17 on. The 17 is up here in this graph. So that represents every real number. So any real number would be a part of this solution set for 16. All right, let's look at the next example. Number 17, we have x minus 3 over 5 minus 1/3 equals 7x minus 3 over 15. So already we see different denominators, 5, 3, and 15. We have to find that least common multiple. And the least common multiple between these three numbers is 15. Once you find your least common multiple, you're going to multiply each of the terms by that LCM, 15. So 5 goes into 15 3 times. We have our 3 here. Copy down your numerator, x minus 3. 3 goes into 15 5 times. 5 times our numerator, but our numerator is just 1 here. So 5 times 1 leaves us with -5. And then 15 goes into 15 one time. And 1 times that numerator, 7x minus 3, would just leave us with 7x minus 3. We're distributing here on the left side. 3 times x gives us 3x. 3 times the -3 gives us -9. We'll carry down our -5, carry down our equal sign, and 7x minus 3. We can combine these like terms. -9 minus 5 leaves us with -14. Now we want to solve. We're going to add 14 to both sides of the equation. And we're also going to subtract 7x from both sides. So that leaves us with 7x, or 3x minus that 7x gives us -4x. -3 plus the 14 gives us 11. And we'll divide both sides of the equation by -4. So x equals -11/4. Now for number 18, we're given this statement. In a certain triangle, the measures of the interior angles can be represented as x, 2x, and x minus 2. Find the measures of all 3 interior angles. So in a triangle, we have 3 inside angles, x, 2x, so x, 2x, and x minus 20. And we're asked to find the measure of all 3 angles. What we know about the interior angles of any triangle is that when we add them together, we get the same sum, and that's 180. So we'll take each of these measures, 1x plus 2x plus x minus 20, we'll add them together, and that should be equal to 180. We're combining like terms. So 1x plus 2x plus x gives us 4x minus the 20, and then we're going to solve this equation. We'll add 20 to both sides of the equation. We'll get 4x equals 200. And then we'll divide both sides by 4. So the 4's will cancel over here on the left. 200 divided by 4 gives us 50. So x equals 50. But we won't stop there, right? Because x is just one of the angles. We still have to find the second and the third angle. So we would substitute 50 everywhere we see x to get the other 2 angles. 2 times 50 gives us 100, and then 50 minus 20 gives us 30. So our 3 angles are 50, 100, and 30 degrees. For number 19, we're told that we have a rectangle, and the length is 4 feet more than the width. We're finding the value of that width, so we just want to know W. So that the perimeter is less than 100. So our length, we said, is 4 feet more than the width. So here, our length, we write as W plus 4. And we want a perimeter that is less than 100. So here we have our formula for the perimeter, which we learned was 2L plus 2W. And if we substitute W plus 4 here for the length, that'll give us 2 times W plus 4, and then plus the 2W. We have to distribute. So 2 times W and 2 times 4. That gives us 2W plus 8 plus the 2W. You combine like terms. 2W plus 2W is how we get the 4W. And then plus the 8. Must be less than 100. So we're going to go to solve this inequality. We subtract 8 from both sides. We'll get 4W less than 92. And then we divide by 4. So W is less than, the width is less than 92/4, or it can be divided evenly into 92. We'll get W is less than 23. Now for number 20, we have to graph this inequality, y greater than 5x. So in slope-intercept form, that 5 is going to be our slope. Our y-intercept is going to be 0. And remember, you always start at your y-intercept. So we're starting at 0 on our y-axis. We're going to go to 0 and plot the point. And then we're going to use this slope. Since it's a positive 5, we're going to move up 5. A positive 1, we're going to move to the right 1. So starting at 0, we'll go up 5, right 1, plot the second point. So up 5, 1, 2, 3, 4, 5, right 1, plot the second point. And look at our symbol, it's greater than. So we should be connecting those points using a dashed line. Remember, when you're graphing these inequalities, if your symbol is less than or greater than, you should use a dashed line to make the graph. If your symbol is less than or equal to, or greater than or equal to, you should be using a solid line to make the graph. All right, so we use dash line here. Now we got to test a point. We're going to test a point to see how we should shade, to the left of the line or the right of the line. Now we can't test 0, 0 since 0 is on the line itself. So we're going to test 1, 1. We're going to test this point here to the right of the line. When x is 1 and when y is 1, is this true? So we'd have 1 greater than 5 times 1. Is that true? Is 1 greater than 5? No, that doesn't work. Therefore, this section to the right of the line, we're not going to shade that section. We're going to shade to the section that's opposite 1, 1. So above the line to the left. That would be our solution to this inequality. Now for 21, we're given a statement. Solve using a linear system. We have the sum of two numbers is 20. So x and y, we'll use x and y to represent the two numbers. The sum of those numbers is 20. So when we add them, we get 20. The difference between them is 2. When we subtract them, we get 2. So our two equations, x plus y, when we get the sum, we get 20. And x minus y, the difference is 2. This is our system that we want to solve. And to solve, we just add the top and bottom numbers together because our y's will eliminate. 1x plus 1x gives us 2x. 20 plus 2 gives us 22. And then we're going to divide both sides of the equation by 2. X equals 11, so that's one of our numbers. Now to get the second number, we'll go back to our original equation, that x plus y. And where x is, we're substituting 11. 11 plus y equals 20. To solve, we're going to subtract 11 from both sides of the equation. So we'll get y equals 9. So the two numbers are 11 and 9. Now for 22, we have 3x minus 9y equals 7. And x equals 1 minus, or 1 plus 3y. Because we have x by itself, we can take that 1 plus 3y and substitute it into that initial, the first equation, where we see x. So instead of 3 times x, we have 3 times 1 plus 3y. We're going to distribute there. Now when we distribute, we'll get 3 times 1 or 3. 3 times 3y or 9y minus the 9y equals 7. Combine like terms here. See 9y minus 9y, that cancels. And what's left over on the left is 3. On the right is 7. Those two terms are not equal to each other. Therefore, we have no solution. This would be a graph of parallel lines, the type of graph where the two lines will never intersect. There's no solution. For 23, we have 4x plus 5y equals 12, and 8x minus 10y equals negative 24. We see that the x nor the y terms will eliminate as is. So we'll work with the x terms and work to eliminate these x terms. This negative 4, we can make that negative 4 a negative 8 so that it'll cancel with the x term below it if we multiply by 2. But remember, whatever you do to one term, you must do to all the terms. So we're going to multiply everything in that top equation by 2. We'll get negative 8x. 5 times 2 gives us 10y. And then 12 times 2 gives us 24. The first equation will stay the same. So we'll just copy over the 8x minus 10y equals negative 24. Now we'll add the top and bottom equations together. See, the 8x's will cancel. Also, the y's are going to cancel. Over here, 24 minus 24, that gives us 0. What we see is the left and the right sides are equivalent. So it means it doesn't matter what we substitute for x and y. What's left is going to be equivalent. Therefore, we have an infinite number of solutions here. Any number we substitute would be a solution to this system. And this graph would be a single line where both of those equations would have the same line on top of each other. So it's an infinite number of solutions. It could be any number on the number line. Now for the last problem, 24, we have negative 3x plus 2y equals 7, and 7x minus y equals 2. We're going to adjust the y term in this second equation by multiplying by 2. We see a positive 2y above it. We can make that bottom y a negative 2y if we multiply by 2. But remember, we got to multiply everything in that bottom equation by 2. So that bottom equation, 2 times 7x gives us 14x. 2 times the minus y gives us negative 2y. And 2 times 2 gives us 4. The top equation will stay the same. And then we'll add the top and bottom equations together. Now, negative 3x plus 14x gives us 11x. 2y minus 2y, that cancels. And 7 plus 4 gives us 11. We'll divide both sides of the equation here by 11. And we'll get x equals 1. Now, that's just one part of our solution. We have the x coordinate. We still got to go back and get the y coordinate. So we're going to rewrite this top equation at negative 3x plus 2y equals 7. But we're substituting now 1 for x. So that's negative 3 times 1 gives us negative 3 plus the 2y equals 7. Solve this equation. We're going to add 3 to both sides of the equation. We'll get 2y equals 10. Divide both sides of the equation by 2, and we'll get y equals 5. So here's our one solution, 1, 5. The graph of this line should be intersecting lines. We should see 2 lines that intersect at that point at 1, 5. Now that's the last problem from the test 2 review. You just want to make sure when you're preparing for the exam that you use the practice test as much as possible. Use the practice test more than one time to be prepared for the